So last time, every object belongs to a class. All instances of objects of the same class have the same properties and methods. Example, all people at StFX belong to the same class. We all have first names, last names, student numbers, and email addresses. So all the class that we might call like StFX student all have those properties. Again, we can put whatever properties we want, but these ones make sense. Although they all have the same properties, each instance will have different values for those properties. Not necessarily, but think of it like if the objects were students, you all would be students, but you'll have different first names and last names, but you all have first names and last names. That's the point. The class is kind of like a template for other things. In C, did you do, for those of you from engineering, did you do structures? Yeah, so it's going to be a little bit like that, a little bit, except much bigger. So why do we like it? Abstraction, like I said with the car, who knows all the inner workings of an internal combustion engine, but who here got to school with a car today? Point is, you don't need to know all those details in order to use it for what you got to do. In the same way that we like functions for abstraction, I tell you to use standard CO. And do you have any idea how that works in the back end? No, but that's okay because you don't need to know in order to use it for what you got to do. So we like classes because it allows us to keep doing like different layers of abstraction. So object-oriented programming, when programming with objects, we have objects interacting with other objects. It's kind of hard to explain until you see examples of it. But there is a difference between the object-oriented style programming and maybe what you were used to in C or at the very beginning of like Python, where we weren't really using objects. Some objects will create other objects. This is common. I have an object that's going to create other objects. Like if I create an object for a course, maybe it'll create like other objects, meaning each student in the course or something. That could happen. Sometimes they'll create a bunch of objects and have them work together to solve particular problems in some ways. Some objects will just be used by other objects, whatever. There's no like rule on how you have to use them. Remember with objects like you're God. You get to create the objects you want. And you get to make them do what you want, and you get to use them how you want. It's all up to you. Unless of course you're following the description of an assignment or something, but that's how you would like do the programming with object-oriented stuff. So this was all very high level, so we're going to go through an example. So this might not make a lot of sense until the end. I'm going to show you a lot of things that you might think like, okay, but what's the point? But it's all going to come together in the end, so bear with me. You're going to, like, trust me, we'll get there. For those of you coming from 161, you've got a bit of advantage here. You kind of know what to expect when defining an object. For those of you that don't have experience writing objects, this is all new. It's going to be weird, it's going to be new. But it will come all together in the end. Let's say I want to write a program to keep track of students in my class. So like I was talking about before, that's the example. I want to write a program to keep track of students in my class. In fact, I wish I used the word course or something because the use of class for this class and class for C++ class can be frustrating, but I'll call it a course. So use for students in my course. So what we're going to do is I'm going to make a template of what a student is. I need to make a class like programming class, not programming class. I'm going to make a class to define what is a student. What does it mean to be a student? That's what we're doing here. I'm going to make a class also to define how I'm going to keep track of all the instances of students. So I'm going to have two different classes. I can have multiple instances. I can have a student instance for each individual in here. And then I can have an instance of a course, like a very specific course for 162. But I could also make a course for, like I can make another instance of a course for Computer Science 215, or whatever else course. Point is, in this particular example, we're going to have a whole bunch of students objects that are kind of managed by another object, which will be a computer science 162 object. Well, instance of a course class object. So what do we want our student class to keep track of? Well, this is where I mean we get to play God. What information do we want this object to keep track of? I get to decide what it's going to be. Realistically, we want to keep track of things that actually make sense for the purpose of our program. So I know last time I was being silly, well, other students are being silly, and you can keep track of like, oh, how many skin cells do I have, right? Like we can keep track of that information for a student object, but that might not be particularly helpful for our current situation. So we're just going to keep track of things that make sense for what we got to do. How about something like first name, last name, oh, is it moving? Yeah, student number, email, and current average. Why not? I could have anything else here I want, really. It doesn't really matter. I can have a best friend. It doesn't matter. All that matters is that these are the attribute, those properties. These are like the facts about a specific instance. So if I created a student object, for you, what would the first name be? What about you? What would be you? There you go. You'll all have first names, but you'll have different values. So these are properties about you, like facts, pieces of information. We can really put whatever we want, but I'm making this up right now. I'm using my brain to say, like, this is what's reasonable, but the point is, I'm inventing this. I get to make it whatever I want. I am literally defining what it means to be a student object in the world of my program that I'm going to write. I'm defining what that means. If you think back to 161, we were using NumPy arrays. Those were objects. Did you define it? No, but someone somewhere defined what a NumPy array was. Someone somewhere defined what a list was. But the point is, now you get to define these things. It's up to you. You're inventing it. Your call. And along with defining these things, there's a whole bunch of things we're going to talk about a little bit later in the course. We get to define things like what it means for two student objects to be equal. Or what does it mean for one student object to come before another object? Like, what would that mean? If I said sort the student objects in this class, what would that mean? If I said sort yourselves, you're left wondering, well, but how? Right? How? You want us to sort ourselves. How do we do that? Do you mean like by height? By alphabetical order, by first name, last name, average, age, whatever. Point is, there are some objects where these values are kind of already given for us. Now I said objects, there are some things. Like if I gave you the number 1 and the number 5, and I said, well, put them in order. What goes where? 1 and then 5. Why? Well, because those integers, those numbers kind of already come with an ordering. Someone told us what the ordering was ever since we were this little. But we know it. We know that two numbers are equal if they're equal. Because that's just what it is. That's how it's like defined. That's the way it is. If you ask, but why? I mean, that's not even really a question you ask, right? That's just like, well, that's just how our universe works, right? But if I say, are two student objects equal? Does one come before the other? You're left wondering, but how? Because it needs to be defined. And we are inventing that stuff. We get to create it. So in C++, we need to start defining a class. Writing the code. And in order to do this, we need two different types of files. This is new for the Python people too. We need headers and then class files. I'm going to warn you that later in the course this will become kind of annoying, but so far it actually won't be that bad. You'll like it. So a header is like what the class is going to do. It doesn't say how it's going to do it. It just kind of says, here's what's going to be in the class. Here's the properties, here's the methods. Just so you know, this is what it's going to do. But in the class file, that's where we'll actually like use the stuff. That's where we'll define the methods or something. Maybe where we will use the properties for things. But there's a big asterisk next to that. You'll see why later. So in the class is how, like I just said. Technically, we don't need a header, but for this class, because I want to enforce like this principle, this design idea of like two files per class, we're going to have headers and classes. They'll be separate files. A header file contains all the definitions of the things that the class will have, the methods, the parameters, and whatnot. The class file is typically where we're going to define how it's going to do what it's going to do. The header usually contains like the includes. You'll put all the includes at the top of your header. And the header file, we didn't need that in Python. I know. Python didn't care about it. You're right. So this is new, if you're used to Python objects. So here's an example of a header for a student class. Have a look at this code. Take your time, have a look. See what you see that's different from what you've seen before and try to make sense of it. I'll give you like a minute. Don't want to rush you. Make observations. And then maybe we'll talk about funny things. Maybe take the time to talk amongst yourselves about what you like, what you don't like, what do you recognize, what don't you recognize but think you might know what it means. Just chat. All right, what do we see?
Private and public.
Private and public. Who here noticed those things and thought, what? Yeah. So, if you were in 161, who here remembers me talking about public and private but saying, you don't need to worry about this then, but you will now? Well, I'm calling it in. You got to know about it now. So, the idea between private and public. This is another one of those things that you're probably going to be, after I finish explaining, you're probably going to be wondering, okay, but why? And it'll make sense as time goes on. But I'm going to do my best to try to explain it now. But understand that if you're left wondering, but why, there is a good reason. If you don't believe me today, you'll believe me tomorrow, type thing. So, private are going to be things like the attributes and the methods. There's no methods defined for the student class that are private yet. Maybe there will be later. But anything that's private, if that code is outside of that class, like if I'm coding and using that object outside of the class where it's defined, I don't know about the private things. If they're private, they are things that someone using this class don't need to know about directly, but the class needs to know about it. So the class is going to know its first name, last name, student number, email, and current average. The class knows that stuff. But the way it's written, because they're private, the way it's written tells me, as another programmer, like I know I wrote this code. But let's say I didn't see this code before, and I look at this, and I go, oh, okay, so this means that first name, last name, student number, email address, and current average, it's information for the class that if I'm using this class, I'm not allowed to touch directly. A lot of times, as we'll probably see later in this set of slides, if not this set, it'll be soon, we're going to look at getters and setters and things. The functions are the methods that will be defined inside the class will be methods that might require their names and whatnot. They might require this information. But the fact that they're private means no one else can access it outside this class. All the stuff from inside this class knows about these things. Outside, they don't. Public is the other big one. Public's just like kind of the opposite. Everyone can see these things. If I put public attributes, every other file in this piece of code could see it and access those things and modify it. But because it's private, it's a restriction. One could actually just make everything public. You might say, well, why restrict yourself? Make everything public. You're right, you could do that, but that's not great design. We like to design things in a way where I would say, if this piece of information, if this method, if this attribute do not need to be accessed outside, then don't let them be accessed outside, because it simplifies the use. If I know exactly, I'm only allowed to interact with this thing 5 ways because it does what it does, and that's how it's designed to be used, only interact with it those 5 ways. When you set it to private, it's a C++ thing. When you go to like build it, and if you try to modify things that are private that you don't have access to, it'll say, no, this code was written in a way that you can't do that. It's like for the programmers. I know you're probably left going, huh? Just hang in there and you will see. As we go up through the course, we will have a lot of examples of motivating the public and private. What things should the users of this class have access to, and what things should they not have access to? It's a nice way of keeping things separate. And it's also a really handy way of ensuring that we don't accidentally screw up the inside of this class. And we might see an example of that a little later. Yeah?
Is private class a key word, or it could be anything?
Oh, private? No, that class is a keyword. It means like this is going to be the definition of the student class. And private means it's private. It's set. You can't call it whatever it's got to be private. Yeah?
Do you have to use that like int main on those? Like where would you put
Int
that?
main?
Like,
Oh.
like your main function?
That would be somewhere else. Well, once you see the example, you'll probably be like, oh, okay. But the main would be like something where I would create these objects, interact with them, and whatnot. This is like in a separate file. Yep.
So when you say like it's private, you can't access it. Is it if you have like a equals 5 inside the private, then you can't change the a outside? Is that what you mean?
Not quite. At least the way you asked that, I don't think, based on the way you asked it, no. It would mean that just sit tight, and I'll show you explicitly how it'll get mad at you. But this is going to fall under a lot of this won't make sense until we get to the very end of everything. And then you can kind of see how, it's going to go like this. It's going to start off with like, okay, wait, what's going on? And then it's all going to come back together, and then you'll be happy. But it might take a little bit. Yeah?
In the public part of your structure, you have both student and like, I'm just assuming it's like non-student. I don't know what's going on there.
It's not student, but that actually is something we'll talk about it. So, student, first of all, notice that this is the same name as the student class. It's like a class of student. That's student. That's the constructor.
Okay.
Squiggly student means deconstructor. Constructor defines, well, how do I create this thing? Deconstructor defines, how do I get rid of this thing? So if I delete this, imagine I made a student in dynamic memory somewhere, and then I want to delete it. Well, it doesn't, for free, know how to delete something of that object. Like, what if this object has a whole bunch of other dynamic things? You'll have to delete those first before. So it kind of defines how to delete it. You'll see examples of this, and it'll click. Yeah?
So in private, like I know in Python you did the underscore before the variable name. Is that just convention there?
Here, so there's, C++ has about 5 billion different conventions.
Okay.
This is like perhaps the more common one. Use it. An attribute that is like these things that like, yeah, the underscore is just private. It doesn't actually mean that it is. If I didn't put the underscore and just called it first name, it would still work. But this is a nice convention. Yeah. Yeah.
There's already a header file action root string. Then why should we use that std string explicitly with all those variables?
Well, because they are, like, first name and last name are going to be strings. So I have to put the type in front of it.
I mean, we have already added the header file.
Yeah. So the header file, by including string at the top, that allows me to create string objects. But just like I get integers for free, I didn't need to import integers, but if I wanted to create an integer type, I would have to say int whatever the variable name is. So because I want something that's a string, I have to be like, okay, string, whatever it is. So I need to have that there. But if I didn't include string at the top, I wouldn't have been allowed to write std : string. I saw another hand somewhere. Yeah?
In the private, like, would you still be able to print out those values in like a main function?
Nope, if it was in a main function, and depends. If I were to try to say like, hey object, give me this thing by just trying to access the attribute, it wouldn't let me do it. But if I had a method that would like return that value, then I could. You'll see. Again, this is falling under, it's going to come together. Yeah?
I just got a question about like the very last bracket. Is there supposed to be a semicolon?
Yeah. I was actually glad someone said that. This is like one of the few times that you need like the semicolon after the last squiggly bracket. Why? Because. All right, we'll move on. All the questions that were asked were very good questions. You're asking the right questions because you're left wondering, but why? We're going to get there, don't get me wrong. But you're asking the right questions, so good job. All right, yeah, public, private, already said it. First name, that's just the convention. These are special methods, constructor and deconstructor. So here is maybe what I will do for my class file. What do we have? Well, we have a constructor, and it looks like the way I've written this, it's like what we would call perhaps a default constructor. It's a constructor that says if someone just wants to create a student object, just assign these values. And they're just some arbitrary default values. I could have called them whatever I want. I decided to call it John Doe, student number, whatever, email, that, and current average is 100, I guess. And for now, I guess the deconstructor is fine to be left alone. We don't need anything special in that deconstructor. That's okay. So this is an example of how I would define, like what I would write in the class file. So let me have a quick look here. So this is the constructor. Okay, let me explain. For those of you from 161, I know you're good with this, but from the engineering, this is new. Constructors are used to mean, well, how do you want me to create this object? The constructor, like if someone calls the constructor, and I'll show you how to call the constructor, it's good, like the computer needs to go set aside the RAM and put what needs to be inside that object. But see how okay, student objects needed they had first name, last name, student number, average, email, they had those values. When I create a student object, it assigns the values there. The constructor does all the setup we need for that object before we're going to use it. In this particularly simple example, it's just assigning some arbitrary default values. We're going to see more of this soon, but that's all we need so far. What else we got? Deconstructor, already said that. Wait, what do I have? Oh, I'm showing the comparison, I guess, now. This is what it would look like in Python. In Python, underscore, underscore, init, underscore, underscore was the constructor. In C++, it's whatever the name of the class was. Same idea, different languages. Not that different, but clearly different. So at this stage, we've got enough code to have defined the object, and the student class is absolutely useless, though we can still test it out to see if everything makes sense so far. So here's what I'm going to do. What time we got? Oh, we got plenty of time. I'm going to create these objects. I've got, if I go here, whoop. There we go. We get rid of this stuff, don't need this. Main, and we won't need this. Oh, we don't need any of this stuff. Whoop. Oh, here we go. This is much better. It's an extended, I can't see what's happening here, so I have to be looking like that. So this is a pretty empty thing so far. I can probably build it and run it, and it's not going to do very much. Come on, it's taking ages. What the heck is taking? There we go. If I run it, nothing's going to happen. It's a really silly little project. Oh, it's because the results here. Clearly, this program did nothing, right? Great. So let's create a student object. Or let's define the student class. I guess that's how I should say it. So I'm going to go over here, right-click, new, add. Okay, I guess add a class. All right? So what's the class name going to be? Student. And look, it's automatically going to create the header file and the class, the CPP. That's where the class will be. Base class, ignore that. And I'm going to say OK. It's doing its thing, and we will see that we now have a header file, and we have our student, our CPP file. The header, leave this pragma once at the top. If you're a Python or a Mac version, you don't need to worry about that, whatever. But this is it. This is a very silly little object so far. I haven't told it about anything. So what I'm going to do is just going to go back to the slides and copy the things over. Oh, did I go too far? Here we go. There. So there, I just copied the stuff over. I've got make it a little smaller so we can put it all on one screen. Still good at the back? Good stuff. So there we go. That's the header. It's fine. It's good the way it is. So now let's copy over the class stuff. So I'm going to go back. So I want to go to the class. Here. Oh. Oh, I don't need two of these. So notice I do need to import, or pardon me, include the header file at the top. And notice that it's not in triangles, it's in the quotes for the ones that we wrote, typically like that. So there we go. I have now written what it means to be a student object. So we've got the header, and we've got that. See how they're two separate files. The header file is a .h, and if you look on, you'll see under the header files thing, seems like a reasonable place to put it, right? Yeah. And then the source file, well, that's where it's actually like defined. So there we go. This code, all I've done is defined what it means. It's not doing anything. I haven't written any special methods for it other than the constructor. So they're kind of useless, but here's how I'm going to interact with them. The heck? Going to include student. And now I'm going to create a new student object. And I like dynamic memory, so I'm going to create it with a pointer and create a new student object. So, what's the type of a student object? Student. So I put student. Student, my S, because why not? Equals a new student. What are you mad about? Oh, it's got to be a pointer. There. And then of course I'm going to be good and delete the thing my S points to, of course. Pay special attention. This will look familiar for those of you coming from Python. You kind of see, like, it won't be that different. But this right here, where I say new, it's the same thing, go, dynamic memory, return the memory location. But when I put the name of the student with the open bracket, close bracket, I'm calling the constructor. And this means all the stuff in the constructor is going to get run. All of it's going to be run. Now, who was it? Someone over here asked the question about public and private. If I were to do, I'm going to go back here for a second, back into the header, and I'm changing this. I'm going to put these two down here under public. Just as an example, to show you what this means. Okay? They're public now. Great. So I go here, and I can ask, what's your first name? I'm going to build this project, and this allows me, oh, what did I do wrong? Oh, is it still running? Let me rebuild it, I guess. This allows me to ask, what's the student's first name? What is that object's first name? Or I guess in this case, it's what's that object pointing to's first name? What should its first name be based on the code we saw? Somebody yell it with more vigor. John. It's John. Great. I could ask its last name. Now what is its name going to be? Doe, exactly. And every single time I run this program, it's always going to be John. It's always going to be John and Doe. That's really useless. We're going to fix this later in a moment. But just so you know, this is silly. If you're thinking, but what's the point? I know. Hang in there. So, of course, it is in fact Doe. But I was only allowed to access the attribute last name from outside the class because first name and last name were public. I'm going to change them. I'm going to put them back to private. And let's see what happens. Let me go back here. There. Save it. Save it. Now look. Member student : last name declared at line 9 of there is inaccessible because it's private. It's saying no, no, no. Whoever, whether it's you or somebody else, whoever wrote the code in the header file for the student object specifically said it's private. And that means you can't access it. Even though you know as a programmer, you're like, but it's right there. But it's private. That restricts it. It's inaccessible. If I made it public, I could access it directly. But here it's saying no. And that's what we want. Even if I try to build it, let's see what happens. Declare, it's the same thing I just yelled at me about. That's a good thing. We want this. It gives us more control over the access. Back when I was first learning about programming, I made everything public. That's bad. Don't do that. I was lazy. Okay. Any questions about any of that so far, with acknowledging I've barely scratched the surface of this so far? You got a question? You're good so far? Anybody else? Yeah.
So there will be more on all this?
Oh, absolutely. I'm on slide like 10 of like 80 for this slide. Yeah.
What's the complexion?
Oh, great question. You mean this right here?
Yeah.
Okay. So it means the same thing, and from those of you from Python, you'll see this in a second. So that means the thing that my S is a pointer to a student object, that means like kind of like dereference and ask it about its first name.
Use like a star.
It's not a star. Well, here's what it's like. If I did this, and this is public, of course, it would be equivalent. So Python, you remember using the dots? Well, in C++, you've got freedom. Because you know it's a pointer, the arrow means like, okay, dereference and ask about the thing. Or you can say like, dereference dot. The arrow kind of is like a two birds, one stone situation. A lot of other programming languages, because you don't have the freedom of like, wait, do I want the reference or do I want what's in there? You don't have to worry about that, so they just made everything dot. We're here. It gives you that freedom. What do you want? That's all. Good question. Great question. Anything else? Yes?
When you're making the class file, do you have to define like a default, like John Doe, different things, or can you leave it?
So, let me get rid of this so it stops yelling at me. It's annoying. You're going to want a default constructor. So I know in Python you would typically only ever have one constructor. But remember how we learned like yesterday or on Wednesday how we can overload functions? Well, we can overload the constructors. We can have as many constructors as we want as long as their parameter lists are different. So we like to have the default one for various reasons that will become more obvious later in the course. But a lot of times we're going to not want to be using our default ones because they might not be the same. Sit tight. Great question though. Anything else? Are we good to move on a little bit? All right. So this was all. Oh. Why is this not working? There we go. Okay. Header file, class file. Yeah. There we go. Okay. So let's think about what's going on here. If I put this. Oh, by the way. Shoot. Okay. What do you think the difference here is? Based on what you've seen so far, this isn't really new to you. What's the difference?
Like a pointer on the bottom, right?
So, this is a student. I'm creating a variable that's going to hold a student object. Great. It can set up all the stuff. It knows how much room a student object needs and whatnot. It's happy. But if I do, what am I? It's this. And then, of course, that student object is going to be somewhere in dynamic memory. But of course, what do I have to do when I'm done? Delete it. Good. Very good. And because it's not an array, we don't need to worry about the square brackets after the delete. So what's the difference here? One's in static memory, one's in dynamic memory. Cool. I really like using dynamic memory a lot because it's going to be more similar to the other programming languages you'll see in your future. Oh yeah, what am I missing in this code? Delete. More functionality. Okay, so currently our class for the students is rather dull. It's pretty boring. So we're going to add a little bit of functionality. We're going to do getters and setters. Getters and setters, especially the first time you see them, might seem like, but doesn't this basically eliminate the motivation for having public and private in the first place? Getters and setters are functions that you will write that allow people allow users of your class to get access to the private attributes. But the reason you want them, there's a bunch. What if your class has 5 attributes, but you only want 2 of them to be publicly accessible? Well, then you only write the 2. What if you want 2 of them that I can access them but not modify, and another one I want to be able to modify but never really access? The getters and the setters are what gives you this freedom. They are very simple functions usually. And another big reason for getters and setters. Imagine I write a getter, or pardon me, a setter. So a setter is a function that will modify an attribute. Imagine I want to modify email address, right? What's the type of email address? It's a string, good. If I gave the user of this object full access, if I made that email address public, then anyone who has access to this object can change that email address to whatever they want. They could turn it into Bob Chair Hat. Whatever. Is that a valid email address? No, that's silly. So maybe what you could do in your setter for that email address is you can do some like data validation. You can say like, okay, if someone calls this setter and they give me a string to update an instance's email address, and that string doesn't have a @something dot something, then I know it's not valid and I won't change it to make sure that that data is like more correct. So the getters and setters also protect it. It adds that layer to make sure that that you're accessing and modifying those attributes correctly, or less incorrectly. Less incorrectly, whatever one, that's right. So that's one reason, yeah, instead of with, okay, yeah, how, why, here's how we're going to do it. So here's my attributes. We want getters and setters. Which attributes here should I be able to get? I should be able to get current average. Should I be allowed to change their current average? Yeah, maybe not. Maybe that comes from somewhere. I don't know. Maybe I should. I don't know. It's up to us. I mean, remember, we're God. We're inventing this. But maybe you're right. Maybe we don't need a getter for that. Or maybe we can get a getter for it, but not a setter. We can access it, but not modify it. Maybe we want that. Should we be able to access their first name?
Yes. Yeah.
Could we modify their first name?
No. Yes.
Maybe they changed their first name and someone's got to be... These are all design decisions. But the fact is, the point is we're asking these questions. Should we be able to access their last name? Sure. Change? Sure. What about student number? Should we be able to access their student number?
Yes.
I think we should be able to access it, like get it. But should we ever be able to change their student number? Probably not, right? I think that's pretty set. Point is, we ask these questions and then we make an informed decision of what getters and setters we want. So which of these should we be able to modify and whatnot? So let's add some of the functionality to the header. Remember, the header's not actually going to say what the functionality is. It's just defining what's going to be in our class, like in our CPP file. So here's the part that's under public. Note that the private stuff still exists above. I'm just not including it here for ease. So we've got public, and I just add all these things. So I have decided to add a getter and a setter for the first name, a getter setter for last name, a getter for the student number, a getter for an email, and a getter for a current average, and a setter for a current average. So I guess for the email and student number, I can access, but I can't modify. That's the rule I came up with. Why? Because I did. I don't know why, I just decided to do it. It seems reasonable, I guess, right? So there we go. I am now saying I'm going to have these functions in my class file. So what's the return type of the first name?
String.
String. How do you know? Because it literally says right there at the beginning of the function, right? What's the return type of set first name? Why? It shouldn't return anything. The setter doesn't give us anything back, it just modifies something. But of course, what are we passing to set first name? A string. Presumably that's the one we want to update the attribute with. Okay. So I'm going to take this and I'm going to add it to my header under public. There. So it's all happy. What happens if I try to build this though? Good stuff. So we've added it. But of course, if we go inside here, we didn't define it. Function definition for this not found. So I guess we've declared it. We have said in the header, oh, this function's going to exist, but we didn't write it yet. So we better write it. Okay, we got to do that next. Oh, there we go. So here's a get first name. I put this inside the CPP file for the student object. Get first name. All it does, so simple. All it's going to do, return first name. That's it. Set first name. It takes the new one as a parameter and it updates first name. There, done. Notice, for those of you from Python, what is remarkably different here? Like, what's not here that you needed in Python? I want to see if what were we going to say?
Self keyword.
Self. We don't need self. C++ is smart enough to know that, like, yeah, you're referring to that variable you declared up there. But because we don't need to declare the variables before using them in Python, that's why we put self to be like, yeah, you're the variable that belongs to this class. But because we declare them at the top, like in the private bits, it knows that they exist, so it's good with it. Long story short, you don't need self. But if you wanted, there is a keyword you could use in place of self if you like the thing of having that extra, more explicit thing, like the fact that you like that there was that self pointer in front. You would use this. This means self. Same thing. This instant. This object. This self. Same thing. Cool. Yeah, literally it. Oh, yeah, and obviously you'd have good comments because you're good programmers. Yeah?
Why doesn't the first one have like a void or like a function name or type?
It does. It's a standard string.
Or just like, okay.
Yeah, it's a string. Its return type is string. Here, its return type is literally nothing, so void. Yeah. Here's the getters and setters for last name. Pretty straightforward. Here's one. Now, okay, we're probably not going to modify student number, so we could just get it. Let's have email. We'll just get it. Current average, return it. That's it. We have to be, oh, here we go. Here's an example of being careful. We're doing some error checking. I decided in my program we're allowed to modify it. But what am I checking here? Before I update it, what do? I make sure that the value is between 0 and 100. There. In fact, in this situation, I actually probably should have made this function return a Boolean, where the Boolean would be true if it worked. If it changed it, good, and false if it didn't check, if it didn't actually change. That would be perhaps a better design of this code. Yeah?
So is the only way that the computer actually knows if it's a getter or a setter is if you type get both like in the name or set in the name?
The fact that it's get and set, that's the convention. If it's a getter, put get, blah, blah, blah. In reality, you can call it whatever you want. It's just the name of the function. Get isn't like a keyword. It's a function, and here's what it's doing. It's going to be a getter. Why? Because getters just return things.
So how does the computer know that you're asking for a getter or a setter? Like what defines it as a getter?
It's not even that it's necessarily defined as a getter. It's just a function. I can define any function I want, and this function returns a value. And functions that only return values we call getters. But it's not like, that's not like Getters aren't a special type of function well defined in C++. It's just a function, and its functionality happens to be that it returns something. And a setter, it's just a function, and we wrote it in a way that all it does is take a value and modify an attribute. But the fact that like the computer doesn't need to know it's a getter or setter. You do as the programmer. You write the function, and then you know that function's a getter. Why? Because I wrote it. And then if I want to call the getter, I'll call that function. We'll probably make it make a lot more sense next week sometime. All right, see you later.